So in this section, we are exploring more angle property of circles, but we will explore them with having tangents in mind. So tangents are lines that just touch the circle. So whenever you see there's a circle and there are some lines touching the circle, you will come to these two properties. So property number 7 is tangent at a point. So tangent at a point is mainly something like this. So there's you can take any point on the circle. So this is called a tangent. So a tangent will touch the circle. So this part is what we'll call the contact point. Oops. So this part is what we'll call the contact point. And from the contact point, if I join to the center, that will become a radius. So there is an important property here. The radius and the tangent will be perpendicular. So this one will be a 90 degree. So remember there was previously another property, angle in a semicircle, that also gave, that also provide you with a 90 degree. So this is another property. So all the 90 degree property are important because it will give you, lead you to some amount of trigo. Okay, and then that is called, sometimes we will say that this is called radius perpendicular to tangent, or you can just say tangent at a point. Okay, so there's another one here. Another one, right, talks about the tangent from an external point. So what we meant by tangent from an external point, that means the point is outside the circle. So this point has to be outside the circle. So it can be very far away from the circle, or it can be very near the circle. It doesn't matter, as long as they are outside the circle. So if you have this, right, you use your ruler, try to connect. Okay, I'm using iPad pencil. You use a ruler, you will connect. So for example, this is A, then you will touch a circle here. So this is a contact point, we call it B. So from this same point, you also try to connect again to the other side. So there is another contact point here. So we kind of shoot out two tangents. We shoot out two tangents from an external point. So the property will be, this is an isosceles triangle. So tangent from an external point, right? The two tangents will be same length. So that is the feature for tangent from an external point. So there will be an isosceles triangle. So sometimes you do need to take note of this isosceles triangle, because isosceles triangle will have two base angles. So what happened when at this corner, where the point is quite close to the circle, but it's still outside. So actually, if you do it, yeah, call it X, and then this is a Y. So you will still form an isosceles triangle. It's just that it's very close to the circle. So that is called tangent from an external point. Okay, so usually this separately, these two property looks like this. But there's a lot of time where these two properties will be combined into a single diagram. So I'm going to show you how I can combine into a single diagram. So the red color one is the one tangent from an external point. So this is the isosceles triangle. So I'm going to use the blue color one. So just now my property 7 was the blue color one. So I'm going to connect the contact to the center. So this one becomes the radius. So this one also becomes the radius. So that will be the 90 degree. So in fact, right, this one will make two congruent triangles. So triangle OAB is actually congruent to triangle OAC. So congruent is the same, is the congruent idea is the one that you learn in Sec 2. That means, right, all the length will match. So these two will match because we already know that they are isosceles triangle. And obviously the radius must match. So that's why you got identical triangle. So if you still remember your Sec 2 work, identical triangle means the angle will also match. So like this angle will match with this angle. This angle will also match with this angle. So if we combine these two properties, we get a pair of congruent triangle. So sometimes it can be quite useful in a long question. So that is the idea of property 7 and property 8.